This 120-meter rocket should collapse, but it doesn't. Hey there, and welcome back to the Booster Bay. We're here to unravel one of the most incredible feats of engineering: how the largest rocket ever built, Starship, can stand so tall without folding under its own immense weight. The answer isn't a single secret, but a masterclass in modern engineering, and we're about to launch into it. The first big surprise, as we know here at the Booster Bay, is the material. While most rockets chase lightness with expensive advanced alloys, SpaceX made a radical and cost-effective choice: stainless steel. It sounds like a step backwards, right? But here's the genius part. Stainless steel doesn't get brittle at the bone-chillingly cold temperatures of Starship's propellants. It actually gets stronger. This means SpaceX can get away with thinner, lighter sheets for the body. And the benefits keep coming. This high-performance, low-cost steel is incredibly resilient and allows SpaceX to build and rapidly iterate on prototypes. For a channel dedicated to rocket development, this strategy is fascinating. Material is only half the story, though. The real engineering magic is in the design. The entire body of Starship and Super Heavy is essentially a massive pressure-tight tank. Think of an empty soda can. Easy to crush, right? But what if you put it under pressure? It becomes rigid and almost indestructible. Starship uses its own pressurized propellants to create what's called a monocoque structure, where the skin bears the entire load. The rocket is built from stacked steel rings reinforced with internal stringers, turning it into one rigid, powerful cylinder. This design is what allows it to handle the immense compressive loads of launch. During a launch, Starship faces enormous stress. The 33 Raptor engines on the Super Heavy booster generate over 16 million pounds of thrust. This massive force is transferred through a heavily reinforced thrust puck at the base and distributed evenly throughout the structure. And then comes Max Q, the moment of maximum aerodynamic stress. Starship's design, honed through rigorous testing,
Booster and ship,
allows it to
avionics,
slice
power, and
through
telemetry
this
nominal.
phase without a hitch. Our viewers at the Booster Bay know SpaceX isn't afraid of failure. In fact, it's what makes this possible. They intentionally push prototypes to their breaking point, even building a can crusher test stand to literally find the limits of the steel design. These explosive failures and grueling tests were invaluable data-gathering missions. Every single setback taught them something new, allowing them to refine the design and understand exactly where the weak points were. So how does the tallest rocket in history not crumble? It's a combination of brilliant engineering decisions, embracing the unique strength of stainless steel, utilizing a pressurized tank design, and learning from every single failure. Every weld, every pressure test, and every test flight pushed the limits of engineering to make this giant a reality. It's truly incredible. Let us know what part of Starship's engineering you find most fascinating in the comments below. If you want more behind-the-scenes engineering and rocketry content, make sure to like and subscribe to the Booster Bay.